Hey guys, and welcome back. My name is Miss Danielson, and today we're looking at common multiples. Now, although I never want you to get your multiples and your factors confused, the methods we use to find common multiples are often very similar to the methods we use for finding common factors. So I hope you joined us for our previous lesson on common factors and prime factors. If not, I'm linking it down in the description box below. Please check that out before we get started. If you've already seen them, let's get started. Factors are whole numbers which evenly divide a value without producing a decimal answer. So the factors of 6, for example, are pretty straightforward. We can divide 6 by 1, 2, 3, and 6. That's it. We're done. Simple and easy. The multiples, however, are the numbers in a given timetable. So if we were asked to list the multiples of 6, it's a little bit more work. In fact, when does it end? We're writing the whole multiplication table of 6. It goes on and on forever. For this reason, when you're asked to find common factors, you're generally asked to find the highest common factor. Whereas if you're asked to find common multiples, you might just be asked to find the first few multiples. Or you're generally asked to find the lowest common multiple. So the first one that you find that matches. You would never be asked for the highest common multiple because it doesn't exist. They go on forever. Now, when we're listing multiples, don't forget to list the number itself. That will always be the lowest multiple. Again, don't confuse multiples with factors. 1 is not a multiple of all numbers. 1 is a factor of all numbers. We can divide all numbers by 1, but 1 is not in every number's times table. So for example, list the first 5 multiples of these numbers. The first 5 multiples of 10 would start with 10 itself, because 10 times 1 is 10. Then we got 20, 30, 40, and 50. Right? The first 5 multiples of 7 start with 7 itself. 7 times 1 is 7. 7 times 2 is 14, times 3 is 21, times 4 is 28, and times 5 is 35. The first 5 multiples of 18. Feel free to hit pause and write them out for yourself. Starting with 18, then 36, 54, 72, and 90. And the first 5 multiples of 24, 24, 48, 72, 96, and 120. You will not be asked to write all of the multiples because that goes on forever. Now, looking at these multiples, I don't see any matches in any of these numbers, but we need to keep in mind that all sets of values will have a common multiple. Eventually, we may need to go on for a very long time to find that common multiple, but it is there. That's why we are generally asked to find the lowest common multiple. That way, we just need to continue on with the times tables until we find the first match, and then we stop. We don't need to go on forever. You will eventually find a match, but it could take a long time, which is why I'll show you some tricks. First, let's try finding the lowest common multiple just by listing out the multiples until we come to a match. So for example, the lowest common multiple of 4 and 3. Start by listing the multiples of the larger value, because you might find that that number grows quite quickly, in which case it'll take the smaller value a long time to catch up, so you might have to skip a few to get to where you need to. So for 4 and 3, I'll start with the multiples of 4, being 4, 8, 12, and I stop there at 12 because 12 looks familiar to me. Is 12 also a multiple of 3? 3, 6, 9, 12. Yes, it is. So I don't need to go any further. The lowest common multiple of 4 and 3 is 12. What about for 12 and 8? Again, we'll start by listing the multiples of the larger value. So 12 first, 12, 24. Now why did I stop at 24? Isn't 24 some multiple of 8? 8 times 3 makes 24, right? Now I can jump directly to 24 because I know that 12 is not a multiple of 8 And there's no sense in me writing out the 8 times tables until I get to 24 if I know that 8 is not a multiple of 12 and 16 is not a multiple of 12. So I jump directly to my answer. My lowest common multiple of 12 and 8 is 24. Let's do the same for 6 and 18. Again, starting with the larger one, 18 first. Multiples of 18? I'm just going to put 18 and I'm going to stop there. Because let's think about this. What are the multiples of 6? 6, 12, 18. 18 is the first match that we have. There was no sense in me going any further with the multiples of 18. And there's no sense in me writing the first few multiples of 6 because they're obviously much smaller than the first multiple of 18. So our lowest common multiple of 6 and 18 is simply 18 itself. Now question D might be a bit more challenging because I've got 3 numbers in this set of numbers. We'll start with the biggest one, so the multiples of 15, and I'll list them out. 15, 30, 45, 60, and I could keep going, but let's try and see if we find a match with the other ones. So the next biggest number is 12. I'll list the multiples of 12, and I'll see if I can find a match for the first 2 values. So 12, 24, 36, 48. Hey, 60! That matches for 15 and 12. Now I just need to make sure that it also is a multiple of 4. Now I could have written all of the multiples of 4 up to 60, but I know that there's no need in listing 4, 8, 12, because those are not multiples of 15. So I skipped ahead until I found a multiple of 4 that's also a multiple of the 2 values above. And 60 is a multiple of 4. It's 4 times 15. Now, of course, you could have listed out all the multiples if you need to, but if you can recognize that and you know that there are no other multiples of 4 in the 15's times table until you get to 60, 12 is a multiple of 4, 24 is a multiple of 4, 36 is a multiple of 4. However, none of these numbers are also multiples of 15. So our lowest common multiple of all 3 numbers in this case is 60. Now I know that last example might have been a bit more confusing, so let's try another similar example. It might take us a long time to find a common multiple though. So we'll try first by listing out again our multiples and see if we can find it that way. If not, I'll show you another way. So for 14, 10, and 6, again, let's list out the multiples of the larger value first. So 14, 28, 42, 56, 70, and it goes on. And I stop there at 70 because I'm looking at my next biggest number. And I'm thinking the multiples of 10 are 10, 20, 30, 40, 50, 60, 70. I've jumped directly to 70 because I can see that that is the first match between the multiples of 14 and the multiples of 10. Now I just need to worry about that 6. The multiples of 6. I'm not going to start listing them from 6, 12, 18 because I need to find a multiple of 6 that is also a multiple of these first 2. That is also a common multiple of 70 because that's the lowest common multiple of the 14 and the 10 which I've got so far. So starting from a number that's close to 70, 6 times 10 is 60, and we'll go from there. 66, 72. Okay, 72 is already bigger than 70. So we're now trying to get a match, a lowest common multiple of 6 and 70. So let's keep going with the bigger of these numbers. Well, 70's times table is 70, 140. Let's keep going with the 6 times tables, and I'm going to need to jump ahead quite a bit to get caught up to 140. So I'm not going to go on with 72, 78, 84. I'm going to jump ahead to a multiple of 6 that's quite close to 140. I know 6 times 2 is 12, so 6 times 20 is 120. Let's jump there. 120, 126, 132. I've gone up to 144, so I've passed 140. They did not match. Let's keep going with the multiples of 70. So 210. Why did I stop there? Is 210 a multiple of 6? Let's keep going with the multiples of 6. Jumping ahead, I could keep going with 144, 150, 156, and so on. But I know that 6 times 3 is 18, so I know that 6 times 30 is 180. That gets me closer to 210. $192, $198, $204, $210. They match. Finally, that took me a very long time, but I'm glad I didn't write out all of the multiples of 6 until I got to 210, because that is my lowest common multiple. I couldn't find one lower that was a multiple of 14, also a multiple of 10, and also a multiple of 6. Now that did take us a very long time. So let's try another method for this. If you remember our prime factor trees and writing our number as a product of prime factors, that is a really good method to help us find the lowest common multiple, especially when that lowest common multiple ends up being such a big number. You may be thinking, but she told us not to confuse multiples with factors, so why are we looking at prime factors? To find the lowest common multiple, it helps if you know what two numbers have in common and their differences. So that's why knowing their common factors, and more specifically prime factors, can help you to find their common multiples. For example, the same example as we've just done, let's express 14, 10, and 6 as a product of their prime factors, and from there, I'll show you how to find the lowest common multiple. Now these are fairly simple factor trees to draw. 14 can divide by the prime number 2, and the answer is also a prime number 7. So that's my factor tree done there. 14 is the same thing as 2 times 7. 10 can divide by the prime number 2, and the answer is 5. So 10 as a product of prime factors is just 2 times 5. And 6 can be divided by 2, and the answer is 3. Both of those are prime numbers. 6 as a product of prime factors is 2 times 3. Now looking at these answers here, you can see that they've all got something in common. They all have 2 as a prime factor, but they're not the same number, not by a long shot. They all have another prime factor that the others don't have. So to find the lowest common multiple, we need to keep in mind that it must be a multiple of 14, so it must be 2 times 7 times something more. It must be a multiple of 10, so it must be 2 times 5 times something more. And it must be a multiple of 6, so 2 times 3 times something more. So the lowest common multiple must involve the prime factor 2 in its product of prime factors. It must be 2 times, it's got to have a 7 in it because the 14 has a 7 in it. It's got to have a 5 in it because the 10's got a 5 in it. And it's got to have a 3 in it because the 6 has got a 3 in it. What's missing from the prime factors of 14 in order to make that lowest common multiple? I'm missing the 5 and the 3, right? What's missing from the 10 in order to find that lowest common multiple? I'm missing a 7 and a 3, right? And what's missing from the 6? I'm missing the 5 and the 7. Now in all three of these cases, although we started with a different number and we multiplied by different prime numbers, our solution is still 2 times 3 times 5 times 7. In whatever order you put it in, we'll give you the same answer. 2 times 3, which is 6, times 5, that'll be 30, times 7 is 210. Regardless of the order you put it in, all of these multiples end up being 210. Our lowest common multiple of 14, 10, and 6 is 210. Exactly the same answer as we had just found by listing out our multiples, but that took us a very long time. And if you understand this method here, you'll see how quick and easy that was. Now I'm sure some of you are looking at this and thinking that looks like magic. It looks like some kind of trickery. Take a minute to copy that example down. We'll go through another example, and then I'll leave you with a practice for you to try for yourself. Now, if it doesn't specify, you can use whichever method you like. So for the lowest common multiple of 24 and 16, if you want to list those out, go ahead and do that. Let's start by listing the bigger number. So 24. So what are the multiples of 24? 24, 48. I'm going to stop there because that number looks familiar to me. Is 48 also a multiple of 16? The multiples of 16 are 16, 32, 48. Hey, that is a match, and that was pretty quick. Now, why was this so much quicker than the previous question? It helps that there's only two numbers here, but also 24 and 16 have quite a bit in common. If I split them down into the product of their prime factors, 24 can be divided by 2, and the answer is 12, which can be divided by 2, and the answer is 6, which can be divided by 2, and the answer is 3. So 24 as a product of prime factors is 2 times 2 times 2 times 3. What about 16? 16 can be divided by 2, and the answer is 8, which can divide by 2, and the answer is 4, which can divide by 2, and the answer is 2. So 16 as a product of prime factors is 2 times 2 times 2 times 2. They have a lot of prime factors in common there. In fact, they're all the same, apart from 24 has got a 3, while 16 has got an extra 2. That means to find the lowest common multiple, 24 needs to be multiplied by that extra 2, or 16 needs to be multiplied by that extra 3. Notice what I've got here on my list of multiples, 24 times 2, or 16 times 3. Either way, it gave us our lowest common multiple of 48. So that one, we could have done either way. How about question B? The multiples of 21 and the multiples of 9, starting with our bigger number, 21, 42, 63. I'm going to stop there because 63 looks familiar to me. 63 is in the 9's times tables, isn't it? Yeah, 63 is 9 times 7. 21 is not in the 9's times tables. 42 is not in the 9's times table. 63 is our first match. So our lowest common multiple of 21 and 9 was 63. Now, had I written out all the multiples of 9, I would have had to write out 9 times 1, 9 times 2, 9 times 3, 9 times 4, all the way to 9 times 7. Or I could use the prime factor trees and see that 9 needed to be multiplied by 7. 21 can be divided by 3, and the answer is 7. That's it. They're both prime numbers, so 21 as a product of prime factors can be divided by 3, and the answer is 3. That's it. 9 as a product of prime factors is 3 times 3. You can see that they both have the 3 in common. However, the 21 has a 7, while the 9 has an extra 3. We'll need to multiply 21 by an extra 3, or 9 by the extra 7. If you look above, I did multiply 21 by 1, 2, 3 to get 63. And as we said before, although I didn't list out all the multiples of 9 till I got to 63, we know that 9 times 7 gives us 63. So our lowest common multiple is 63. For the multiples of 22 and 5, starting with the multiples of 22, we've got 22, 44, 66. Oh, that's a shame. You might have been hoping for 55 like I was. All right, let's start with the multiples of 5. I'm not going to start from 5 because obviously that's way smaller than the first multiple of 22. I'm going to jump ahead to 5 times 11 is 55. And then 60, 65, 70. Okay, this is getting quite big and I'm not seeing a match here. So let's go on and have a look at our factor trees. 22 can divide by 2 and the answer is 11. Those are both prime numbers, so 22 as a product of prime factors is 2 times 11. 5 is a prime number, so there's no sense in breaking it down. However, as you can see, 22 and 5 don't have any prime factors in common, which is why it's taking us so long to find a match. In order to be a multiple of 22, it must be 2 times 11 times something more. In order to be a multiple of 5, it must be 5 times something more. As they've got nothing in common, the lowest common multiple must be 2 times 11 times 5, or 5 times 2 times 11. Either way, 5 times 2, that's 10. 10 times 11, that's 110. The lowest common multiple of 22 and 5 is 110. So you see, even if there's only two numbers that we're trying to find the lowest common multiple of, it might be helpful to use the factor trees if you're not finding your answer quick enough. Let's try D, 13, 16, and 18. Starting with the biggest number, the multiples of 18 are 18, 36, 54, 72, and so on. Let's try and catch up with our multiples of 16. 16, 32, 48, 64. I'm not catching up very quickly. 13. Now, I'm not seeing any matches for any of these. This is taking me a long time and I can't figure it out. Again, let's try with the trees. 18, we can split down to prime factors. 18 divides by 2 and the answer is 9. 9 divides by 3 and the answer is 3. So 18 as a product of prime factors is 2 times 3 times 3. 16 as a product of prime factors, we've seen before already, it's 2 times 2 times 2 times 2. So that just leaves 13, which is a prime number as it is, so 13. The lowest common multiple of these three numbers is going to take a while to get to because they don't have very much in common. While 18 and 16 have 2 as a common factor, 18's got 2 extra 3's, 16's got 3 extra 2's, and 13 has got nothing in common with the other numbers at all. So that lowest common multiple would have to be 18 multiplied by those 3 extra 2's and multiplied by the 13, or the 16 multiplied by the 2 extra 3's and multiplied by the 13, or the 13 multiplied by 2 4 times and then multiplied by 3 twice, just to be a multiple of all three numbers. Now that would have taken us a very long time to list the multiples to get to that point. But that lowest common multiple, and I stress it is the lowest possible match, is 1,872. So as I've shown you how to list your multiples out till you find a match, you can see that sometimes the tree is the only way to go. Let's get on to some practice now. Find the lowest common multiple by whichever method you prefer. Now, question 1, I really do leave it open to you to choose the method you prefer. But question 2, you might notice, gets a little bit harder to list those multiples until you find a match. So consider using the tree if you get stuck. Go ahead and hit pause now. Copy the questions, please, and show you're working whether you're listing the multiples out or you're making prime factor trees, writing the values as a product of prime factors, and working out the lowest common multiple that way. Go ahead and hit pause and press play when you're ready to take up your answers. I hope you had a chance to hit pause because here come the answers. For question 1A, 6 can be split down to 2 times 3, and 21 can be split down to 3 times 7. You see they both have the 3's in common, but 6 needs to be multiplied by 7, and 21 needs to be multiplied by 2. So our lowest common multiple is 42. If you listed your multiples out until you got to 42, that's fine. It shouldn't have taken you too long. For question B, as you can see, the 9 still needs to be multiplied by 2 and then multiplied by 2 again, while the 12 just needs to be multiplied by 3. If you listed your multiples out until you got to this number, it shouldn't take you too long. 3 times 12, or 4 times 9, is 36. Question C, 15 is 3 times 5, while 24 is 3 times 2 times 2 times 2. So clearly 24 needs to be multiplied by 5. And 15 needs to be multiplied by 2 times 2 times 2. You could list your multiples out. That would just be 15 times 8, or 24 times 5. It's just 120. Question D, when there's 3 numbers that you need to find the lowest common multiple of, it is a little bit more work. But in this case, we do see that these numbers have something in common. 10 is 2 times 5, 25 is 5 times 5, and 15 is 3 times 5. So for the lowest common multiple, we'll need to multiply 10 by 3 and another 5. That's 10 times 15, that's 150. Or we'll need to multiply 15 by 2 and another 5. That's 15 times 10, 150. Or we'll need to multiply 25 by 2 and 3. That's 25 times 6. That's 150. For question 2, these ones are a bit more difficult because they didn't have as much in common. 5 is a prime number and 14 is 2 times 7. So the lowest common multiple will be 5 times 14 or 14 times 5. That's 70. For question B, 8 and 27 also have no prime factors in common. To get the lowest common multiple, we'll have to do 8 times 3 times 3 times 3, which is 8 times 27, or do 27 times 2 times 2 times 2, that's 27 times 8. That's 216, which would take you a while to get to if you listed out your multiples. For question C, 5 and 16 are relatively low numbers. However, 5 is a prime number, and 16 has no common prime factors with 5. So the lowest common multiple would end up being 16 times 5, or 5 times 2 times 2 times 2 times 2, which is 16. 5 times 16 is 80. And finally, question D. Although these numbers seem to be fairly close together, they have very little in common. We would need to do 20 times 3 times 7, or 15 times 2 times 2 times 7, or 21 times 2 times 2 times 5. Either way, our lowest common multiple is 420. Now, how did you manage with that? I'd be really interested to know who prefers to list out their multiples and who has really got the hang of this prime factor tree trick. Now, if you like listing out your multiples rather than using the tree, that's fine. It's good that you can find a method that you're comfortable with. But I hope you've learned the value in this new method and you're at least willing to give it a go, because in future it's going to be really helpful for you. I hope you found this lesson helpful and interesting. And till next time, keep practicing, and I'll see you soon.